Welcome, welcome. Hello, guys. So today will be a little bit of a boring debug stream, I think. Not sure, but I have no high hopes, to be honest. But maybe we can solve the problem rather quickly, and then I can see what else I can also bring to the table today. Now, basically, let me just quickly introduce you to the topic. What's the problem here? So this was a basic model which we were using, and this model has just two plates, and it has an RBE connection here, which is the point of interest. So what I would like to do with this tool is to get automatically the force which is transferred with this NPC. So that's the target, and I also could achieve this by just having the user setting properties to each plate. So every blue and yellow part have different properties, and with this condition, the model works, so the code works. But this is not really a great design. So basically, what I would like to do is make that automatically. So what do I mean by that? I mean that an NPC can can execute a method which just separates the slave nodes of the RBE into different groups. So just imagine this element here. It has a group with the upper nodes and it has a group with the lower nodes. And I want this to be completely automatic. And for this to happen, the following algorithm is proposed. So I start with a node, could be any slave node, right? Could be one on the yellow side, could be one on the blue side. And then I just connect every blue element together and see what are the nodes which are taken by blue. Then I do the same thing taken by yellow, and those are my groups. And it's failing, I think, because of the neighbor relationships. As always, if you have any specific questions about something related to Python or Hypermesh, you can also ask me right away. So I will also gladly skip or step away from doing the debugging, but not quite now, but maybe in a couple of minutes. But yeah, so yeah, good evening, Alex. Yeah, so welcome to the stream. We have been exchanging messages on LinkedIn about some rotationals. If you want to get some additional input to that, I'm happy to provide this today too. So if that's something we could try on stream, that would be also something maybe more interesting than doing the stupid debugging stuff. But yeah, let's start with the debugging stuff. Okay, so here's my playground. That means this is a main method where I also changed Visual Studio Code preferences to launch this. When I press F5, so this works, I can also properly debug then. And basically I commented out this thing because that's where we had the trouble. It's the neighbor relationships and everything that worked quite okay, but we did not test it. But here we had a problem. And the problem was this, that we had like 15 or 17 or 70 groups of different node sets, and that was not really great. So basically, I suspect that the neighbor relationships is wrong. So I wanted to have something with debug this. So element get neighbors is our method which just gets us the neighbors. That means it calculates the neighbors for every element. But it does that a little bit with efficiency goal in mind, right? So it doesn't do it with something where you can say that it's a foolproof strategy, because there's still some parameters which can be affecting the output of this calculation here. But this foolproof strategy is computationally very inefficient. But I will do it here now anyway, and we will see how bad it really is. But it's pretty bad normally. Let me get back. So basically what I want to check in this block is for every element in the elements I want to have my neighbors. So those are neighbor elements. I think those are elements, not element IDs. Now, those are the neighbors I calculated, yeah? So these are the neighbors I think which should exist. Now, here doing the stupid computational inefficient strategy. And now let me continue doing this. So the potential neighbor. And then, yeah, so the first block is correct. So if the element ID and the potential neighbor ID are the same, because that could happen, because I loop over all elements and I loop over all elements twice. So I have maybe sometimes the same ID, and that's not a good thing. So I want to skip that. So that's a continue. And it's also good to push this to the top. So that means that's the principle of fail first, or fail first. Yeah, I think that's how it's called. Because we don't have to execute anything below it, because we know we have to skip it if this condition is met. So always check your continuing conditions at the top. That's a good design tip. Now, if set element nodes intersection potential neighbor nodes, so if there is something nodes in common, right, then I would say I add the real neighbors. Now, and then I will say if the neighbor I have and the real neighbors are not the same, I will print something. And if that worked correctly, this would never get printed because, yeah. Well, to be honest, length check isn't really the best idea. Better it would be that it would have the correct elements. So not just the same amount of neighbors, but the correct neighbors. Could we use the intersection again? Yeah, maybe that works. Maybe it doesn't. Let's see. I'm not sure about this, to be honest, right now, because I'm not aware of how this set thing really works. So is order change something to account for? Not sure. So I would rather have something like intersection. If I do the intersection of it and then say that it should correspond to the length. Yeah, I'm not sure if this is better. So what I do here is I first do the intersection of it. So that means that the ones we have in common, and that should be the same length. But to be fair, I should then also check that the lengths are the same. So both neighbor arrays have the same length. So we have the same amount of neighbors. And if I do an intersection, it still has the same length. So that means all nodes or all elements in one set are contained in the other set. Okay. And I check if that isn't the case. And that if that isn't the case, I print it. Okay, let's see. Let's see. If we see something, we can abort and check it, because normally there shouldn't be anything printed. Yes. Okay. Non-type object is not iterable. What is non? Neighbors. Neighbors is non? For which element? Hmm. Wait a second. What is this? First of all, why is it like this? Should be like this. Now let's see what it is. So class element is the correct class. I have all elements of that, but now here I should have something like neighbors, but with this. And then I have the get neighbors. Then I should maybe check if the neighbors are correctly written here. Comments, comments, comments. No comments. Yeah, you see something very simple like this can have impact breaking your code. Maybe I should have went with the English version of writing this and not stick to the American. Okay, let's see. You know what? We replace that neighbor. Yeah. Okay, but I'm not sure if I maybe did miss something. I didn't. Okay. All right, and something else which I think is good to have. I want to see a counter. I want to see how fast this is. No. Okay, something like this. Counter of length elements, all elements that... Now I can see how fast this is going. Yeah, you see that? That, my friends, is not good. Oh, and I see I had a bad connection coming up. Yeah, sorry. I think the small recap was already done, right? So Alex, maybe you can shoot it again. I think we have a delay here. Let me think. Could the lag be introduced because of the thing here? No, it doesn't look like. But yeah, so while this is running, I can maybe recap a little bit of what I'm doing here. So neighbors, what are neighbors? If you think back to the elements here, wait a second. So you think about those elements here. So I'm just talking about the 2D and 3D elements later on. Those 2D elements have neighbors connected to them. And the reason why I'm interested in having this relationship to it is because I want to be able to add all the neighbors here and then go again and add those again. This is the way how I grow. That means if I start with the slave node here, I get the element, which is this and this one. Those are both connected to this slave node. And now I grow. I grow until I don't get any more elements, and that means I have all the blue elements. But if I have all the blue elements, then I have all the blue nodes. And if I have all the blue nodes, I can make an intersection with the blue nodes and the nodes, which are the slave nodes, and have exactly what I wanted. It's this group of nodes right here. Same thing can be done then with the yellow one, because just think about it. I have this element, the number of slave nodes here are taken away from the stack. That means I don't have to care about those anymore. And I can fully concentrate on the ones here. To be honest, I don't really have an idea how many groups there are, but I'm starting again with one of the nodes. Then you see again with the neighbor connection, I will grow and have every yellow element eventually. Then I have all the yellow nodes, and then I make an intersection between the yellow nodes and the slave nodes, which are then just those nodes here. And then that's the second group. So basically that's it. That's it, what I'm trying to do. So we are here now at 10K. I will abort this. It doesn't seem to me that the neighbors are the problem. Right? The neighbors are not the problem. It could also be that it is something trivial, what I don't see right now. That could be it too. And I have to think about this right now. If I just execute this code once more and just see if it works like what I intended it to do. So basically I have the neighbors, which should be something like 13. What is this element? First of all, yeah, so the neighbors are here. And those, I am here to believe that a neighbor should have that. What? Well, I cannot believe that, to be honest. Now let's move forward and just continue until here. Now we have real neighbors. And the length is 7. What? And this is still working? So what is this? So if I have... Ah, maybe I have duplicates here, right? What if I just add this to a watch? Length is 7. Oh, interesting. So I have a lot of duplicates in the neighbors. Okay, that's a problem. But it's not a problem from a functioning perspective. But still, let's still get rid of this. So there's duplicate neighbors. Why? Um, so I have a potential neighbor, and there's this check that if the element is not in the potential neighbors, then element neighbors. I think I got it wrong here. So if the element, so which element are we talking about? I think those are flipped, right? So if the element is not in the potential neighbors group, then I say append this element to it. And the other one is if the potential neighbor is not in the element neighbors, then the element neighbors is to be appended the potential neighbor. I'm still not really sure if there's any benefit. So I sense there is a benefit of doing this because you have the relationship already. But on the other hand, I think I miss something here to remove or keep track of something to not to fail first, something of that. But that's out of the window for right now. Yes, Alex, correct. A set should be uniques. That's perfectly it. The thing there's a reason why I stay away from sets normally. I'm not sure what it is. If I cannot index it or something like this, I'm not sure. But I have to do this maybe because you could also do just a stupid calculation and do all of this, and basically at the end calculate it as a set and be done with it. Yeah, so, but this should definitely help. Let's check again by running the code and see if now my neighbors and real neighbors lengths are comparable. So I will continue to this line because then I can check it. So the neighbors should have done 7, yes. And this is what we have fixed now. And real neighbors should have 7 as well. So basically, I'm not sure if it's the case, but basically this could also be the problem for Richard here. But not too many hopes for right now, but let's see. I will just comment this block out for checking the neighbors, because I'm assuming that the neighbors should be not a problem here. And go on and just run the code again and see what the original problem is. The original problem meaning we have the problem that the output is not valid. So it calculates like 17 groups and it should have 2. Oh, and I still have some debug option on here, which prints out elements to be found. So I'm not sure what this exactly is, but those are elements found. Is this a beginning? No. Well, those are elements to be... Oh, we fixed it. Huh. The forces are wrong, but we have now 2 groups. No way. No way. No way. We have two groups. So let's check that. So this is one group, hopefully, or not. I'm not sure, but let's suppose this is one group. I will copy that because this is a debug print we could use. And where can we use that? In the element selector. But to be honest, I think it's too far to less elements. So I would like to add elements by ID. And that's done here. Then I paste the string I just copied in. Okay. So that looks reasonable, but I think it's not all. Yeah, so maybe we were just lucky. Because I will now copy all of the element. I'm not sure what I really printed there, but normally I would suspect that I would have two groups. One is all the yellow elements, one is all the blue elements, and that's it. Then I could say, okay, I think the code is working, but now I'm not a bit confused. Huh, see? It doesn't work. Okay, so it's not really working, but or maybe it's just a debug out. Who knows? What did I print here? Um, what did I print there? So print rigid some forces connect. This is the last line, but I think in the MPC forces to get node to forces, I printed out I think something here. Get node to forces. Not sure if it's that. Could also be in the get rigid elements. Here somewhere. No. Where is this? Is it in the entities? I'm pretty sure it's in the entities. Yeah, it's this get all connected. Yeah, it's this one. Get all connected elements. This is being printed. Okay, we still have a problem. We still have a bug here. Why I know that? I think I know that because the console output is incomplete and the forces are all messed up. So the force is what I would expect. I would expect to have two groups. So basically I have that. But the two groups should be of forces like 500, 0, and minus 500, 0. This is what I would expect. Yeah. How could we debug that? I sense that there is a problem here in this method. Get all connected elements. It starts with an empty list. Alright? And if it's an empty list, or it has the self in it, that could also be, then we have just the self. And then this loop thing. I'm still I'm still not a big fan to have this with recursive method calling. Good point to write it to the text file. Yeah, not a bad idea. I could do that. But let me quickly, before I do that, get rid of this. I'm not really sure if this is working. So basically, the condition that the length after and the length before is the same, if that's the same, I return the connected elements. And that means that this loop here, so for every element in the connected elements as it is before, for the neighbor in the elements element.neighbors, if the neighbor is not in there, then I would add it. To be honest, I think this is a perfect strategy. That strategy should not fail. Because let's just think about what we have seen here. We have seen some elements like this. And I think there was some elements missing here. So if I loop through all those elements and then through all their neighbors, if the neighbor relationships are correct, then this would get added, right? This would get added, and then I would have a different length. I can only think of something like an internal max def recursive function, but on the other hand, I would say that there should be then an exception, right? But to be honest, the problem here is that the print command is on the wrong position, because that position is just before having another loop of it, right? So to be honest, it should have been there. But yeah, Alex is right. Have it written to a text file does a better job. Yeah, something like this. Where could we write that to? There should be a data. Then there's output. Let's say data output. And then we just have to think of something like an identifier. Hmm. We have to import something for that. Yeah. Okay. Let's see what this is going to get us. Nothing to lose. So it should be appearing here. So this is one file. Seems like a little bit more, right? Let's see. If those are all the yellow elements, I'm freaking out of happiness. The blue is also good. Maybe there's also a max cap for this. So 798 is the last thing. Yes. I think it worked. Now the only thing it didn't do is the forces. The forces is just a mess, right? That doesn't make sense. But to be honest, that's not a problem. That's not bugging me to the least. Hey, Big House Bros, what is this? Yeah, basically that's an hypermesh file which has NPCs in it, and I like to get the force transfer of it and do it automatically putting those nodes into groups without any knowledge about anything but the element connectivity. So this is what I'm doing here. And this all flows into a tool called HyperWorks Tools, or no, NPC Forces Tools, SPC Forces Tools. Yeah, so this is just yeah, a little program which helps with that. And yeah, so the reason why this is a good thing is you can then do stuff like automatically getting the forces for screws, which you are modeling with NPCs, in a big model with lots of NPCs, because that's normally a pretty awful job to do manually. Yeah. So I'm automating away the boring stuff. Book title, not my book, but it's a pretty good one. Yeah, so I think that's not bad, right? So I think we just had a problem with the console output. I'm not sure why though. Somehow it just stopped. Yeah, and we had a print statement at the wrong line, but yeah, Yeah, that was the problem. The print statement was at a wrong line position. Yeah, be careful with the print statements. Let's just check the other one too. So I wrote that to data output, and we checked the 128, and now let's check the other one too. But I'm pretty sure this will be the yellow ones. Yeah, bit too much. Yeah, it's correct. And I'm pretty sure that works for 3D elements too. So, yeah, it's pretty cool. Yeah, I think so too. It's pretty nerdy, that's for sure. It's pretty nerdy, but I like it. All right, so let's skip away this length before, this right whatever to. We have to do tests for this, but yeah, long list of to-dos. First of all, I want to make sure that I get the right forces. So this should be in the MPC forces reader. Or maybe it's all no. It should be not in the nodes normally. Because it correctly separated the slave nodes into two groups. So I'm assuming it correctly separated it. So I think the problem is more with the summation of the forces. Yeah. So that's it. I think we can go to the sum forces. Where is this actually? Should be in the MPC forces reader, right? Here. Get node to forces. Well, I did not change that here. No, it's not here. It's not here. It's in the here in the rigits. So some forces, that's the new method, and this is wrong. So we have the node IDs, and we go now through each node ID. If there's a problem, then I have something with a print. That's not happening, so I would say this should be it. And then force is node ID to force, and with the node ID. Then I have my 3 forces and 3 moments. That should be the same thing like I did it before, right? Force X, X, Y, Z, moment X, Y, Z, and same thing. Here we have a part ID. Yeah, we didn't have a we didn't have a part ID. But there should be part IDs, 2 of them, and then I should return that. And this is exactly what I have here. I have a part 1, I have a part 2. And we have forces for part 1 and part 2. So basically, that should not be a problem. Maybe we have a problem with the nodes. But let's see. Let's see. I will just make a debug breakpoint here and have the model run. Oh, it sucks that it takes so long. We have to definitely make it more efficient. I'm feeling that we can have at least a speed up of 2 to 3 times. 2 to 3 times the speed of what we're having right now. So, in part ID to node items, yeah. So you see we have 2 groups. Oh, and they are pretty not same length. They are? Okay, so that seems good. Let's see if can I maybe copy value? Yeah, that makes sense. Let's just see if that is what we expect that to be. So if I just say I want nodes and would like to, I would also select that by ID and just paste in what I had here. Oh, cannot paste it in. Why not? Well, there's no way I can get that. Yeah, I have to print it. Ah, something like this, yeah. Okay, let's see. Oh, it's not happy about it. Maybe because of the brackets. Wait a second, I have to save a text file that I don't lose that. Okay, I'll paste it in and we'll remove the brackets. Paste it in again. Now, if we have correctly had the slave nodes, then I would say that that should be. Yeah, so this is all the blue nodes. Okay, so we're confident that the node IDs is the correct one. Now, let's see. The node ID to force, what is it there? So the length would be 39, and I have some values there. The values are not that big. Oh! Is this the model with the RBE3, right? Then I think that the forces make sense because that's a different story. That's a different story. I think the code is correct. Oh man. So that means I can now switch the path to be. Let's not do the 3D bolt because that's just too much to calculate. Let's do the rigid. That's the RBE2, and for that it works. Hopefully. It always takes so long. That's really frustrating. Okay, but I think the code is correct. This should now output the 500 newtons in each direction. And the RBE3, because it has a different formulation, that is a different story. So we have a comment here from Yash. Hello, have you worked in C++ and Qt? Yeah, I have worked Qt. You mean the GUI framework for Python? I had some minor things which I did there. Nothing too much. C++, I avoid like rain. I'm not sure why. I had, I think, the opportunity to go into C++ a couple of times during my PhD thing, but I always stick with, well, I had to do Java because of reasons, and then I did not do another language. So Python is just for my go-to thing, where I do prototyping and stuff. I flirted a bit with Rust, but Rust is a different kind of animal. And C++, there's a gazillion ways of shoot you in the foot with C++. So where I know that the benefits and speed are pretty good, I think you can cover many things with just plain Python. And if you have problems regarding the performance, I mean, something like NumPy, right? NumPy is Python, but internally it's transferred to C or uses C libraries. And so I hope that I can stay on Python pretty much the whole time. Sorry about my screen just got off. I can stay on Python and just use library. But let me just see that I understand you correctly. So PyQt5, isn't that so Qt is, in my head, it's something which is the GUI version, isn't it? Yeah. So PyQt5, if I just do a quick Google search, so this should be a GUI framework for Python. Yeah, I did something with that, but just if, well, to be honest, it works like that on my professional life mostly. I create a tool. If I just use the tool myself, then there's no need for a GUI. I rather use config files like YAML files, which I can change down and run it again and stuff like that. For me, there's no need to use a GUI. But if my coworkers wanted to use that tool as well, I have to create GUIs. And that's why I have quite some experience with Java Window Builder, which is horrible. And Qt is also not something pleasant. I flirted with the idea of doing something with a web browser because I think that's a far better solution to have something with a front end. But on the other hand, I'm not a front end guy, not at all. I don't know JavaScript, not one line, and I hate JavaScript to the core. Why? I mean, just think of, yeah, types, performance, the npm debacle. It's, if you are a full-time programmer, and in the front end business, you have to do it. There's no way around it. But it's nothing I would try to do. It's, yeah, well, you should never say never, but yeah. So Alex, has a question. Do you know how to create a plugin for Hypermesh GUI? I did something with that, but very, very prototypic stuff. Nothing really advanced. Because same thing, the Hypermesh tools are used only by me. And I another programming language I hate to the core is TCL. TCL is just uh, uh, yeah, I'm not, I'm not trying to do a rant here, but TCL in Hyperview especially drove me crazy. Really, TCL is the shit. But yes, so I stayed away from TCL to the point that I rather would program something in Python, like the complete logic is in Python, right? Just Python. And if I ever needed something in TCL, I would generate the TCL from my Python code. So basically, what I also did was creating a Python code, which then creates a TCL code, which then runs Hypermesh, for example. So, for example, simple example, I did do some stuff where I had to separate elements or cluster elements together. Something very similar to what we are doing here. But just think about structures from a topology optimization, and you have to reconstruct the geometry from it. You would like to separate the elements you have and try different algorithms. And for that, you would need visualization. So one could think of doing a PyQt GUI, which then can read in some element data, do a simple 3D plot like this, which you also could move and stuff like that, program all that stuff. No. What I did, I was using Hypermesh, and I was creating a little script where I could enter a dictionary from Python where I would know, okay, those elements go here into this collector, those elements go into this collector, and then from Python, I created this TCL script which just moved the elements around. And so I had my visualization. So the elements are then colored differently because you can just think of it that you have a bunch of components here, right? And putting the elements there, then you can auto color it. And so what I did was, using the 3D plotting functions from Hypermesh, but programming the logic of my algorithms in Python and using TCL as an interface to command Hypermesh what I wanted to do with the data from Python. And I think that worked pretty well. Keep the algorithms in a programming language which you know, which you like. And if you have to change programming languages because of some things, there's always a possibility to mix it, to mix programming languages. So there's just nothing gets in your way to execute some system level code from Python. Like I did some testing with OpenPose, which is a program which can detect skeletons from video images, and I did that in Python. And I have to use FFmpeg because the frame rate was not available and stuff like that, and I had to split it into images and whatnot. So I just used a system command executed from Python. So like just a FFmpeg system command executed in my Python code, and I could stay in Python, let the algorithm and all those things stay in Python. And if I need something from the system, I would just make an interface. Like, yeah, something like that's very simple stuff to just use functionality in Python to command something in a different language. So yeah, maybe it's not the best program design for a very fast and stuff program, but it is for a prototype. It's much faster, much faster. I try to limit the number of interfaces I have to code very much. All right, now I think the results should be there. Oh no, it is stuck at a debug point, but I have trust that it works. Yeah, not sure if it really worked. It seems right, but it could be off for a couple of newtons. Because I think it should be 500, not 483. Am I missing something? Let's check. So we know the model, right? The model would be, we're on the playground. So the model would be the plate simple rigid. And that means we can look into the data. Data input plates simple rigid, this one. And if I look here, this is what we have. And I will just simply copy that out and go to my beloved Excel. By the way, also a tool I hate to the core. Not to be honest. To be honest, it's not complete hate. It's if it's used for more than what it should be, then I hate it to the core. It's just awful. Yeah. Oh, wait a second. Okay, it works correctly, but this thing cannot be put into Excel correctly. It will just ignore all the spaces here. But I think that's my mistake because there is a way to have a block-sized input in this thing too. But let's, yeah, I don't want to see that. Now I will just check, and I know that by the element IDs, which are the groups. Yeah. Okay, we still have a problem. Not so great, not so great. So it turns out to be 500. And yeah, and it's not 500 here. So we're missing 20 newtons. We're missing maybe one node. We're missing one node. Probably one node. So that could be also a hint what's the problem. That's definitely here in Richards. So the nodes, how is the nodes generated, right? It's yeah, so I think the problem is here, connected nodes. No, it's not a problem. What could be the problem? There's no error. That's a good thing. I think we still have to go to debug this a little bit more. And see if we are missing a node. That it takes so long is not good. I know I'm repeating myself, but so as I know, the problem is on both parts. So I can just simply go for one of the node IDs. Doesn't depend on which one. And check the node IDs again. Copy that completely. Just making sure that we are not missing any node here. Because that could be it for sure. So now if I remove the braces, just copy the thing which we need and then say nodes by ID, paste it in, select OK. And we see that we're missing one node. So that would say that then I would say we are missing maybe one element. Or maybe this was the starting node. So this was my initial thought. That somehow the starting node or something like this was being taken away. Can I see the elements? No, right? If I have this node, this would be 10388. 10388. Just making sure that I'm not missing it. All right, 10388. The thing is it in here? I cannot print something here, right? This doesn't make sense, but I know the connected nodes numbers. So 9941. Okay, I think I can work with that. So let's just think about doing something like selecting all the nodes. Something like this. How many? 10. 159. So there seems to be a problem going from elements to nodes, because the connected nodes seem to be not correct. We checked the elements, that the elements are correct, but we did not check the nodes. So that means I get the connected elements here, then for each element in the connected elements, for each node in the element.nodes, if node is not in connected nodes, then append it. I would say this is a good strategy. So the problem can only be then something which comes from either the elements, the nodes are not assigned to the elements. Yeah, exactly, Alex. That was my thought too. Is it the initial, but the initial one? So let's see again. So this is the method, right? So we have the node stack is self.nodes. Why? What is actually this? Ah, yeah. This is a slave nodes. Should have named that better. So slave nodes is that here. Then the node is node stack.pop. So I'm removing the node stack. Then I get the connected, then I get one element which is connected to it. And then I get all the connected nodes for this element. So to be fair, this connected nodes array, this is not something which is I think I found it. So you see here the node stack is self nodes. I think this is by reference. This is not by value. And by popping, no. To be honest, no. Because if that's the thing, then it should remove everything. But still, I'm not sure if it isn't. So something like this would be definitely better. And see, I try to get it here. That should be a little bit quicker than before, and then we can see if the connected nodes is actually working. Yeah, let's go one step further. I know this is not taking all the elements from one side. Now the question is, if I have now the connected nodes, and I should be able to, I just have the 159. On which part is it? Let's hope it is this one. Yeah, it's exactly one node missing. And there, yeah, okay, so, okay, it is missing one node. It's missing one node. But why? So let's see if the self nodes has the length of 92. Let me see if that was the case with or without the missing node. I have again the selection from before and do that here again with the by ID. So how many is that? Cannot see it. that was. Stupid. Again. So 46 nodes should that be? This is with the missing one, right? So yeah, so 47 would be correct. 47 would be correct. Now, the intersection, I already know those will be then the 47. But now here, it's 92, 47. And let's see what the other one is. Here, what do we have here? 92. So 92 nodes. Okay, so the problem is not here. In the self.nodes, this is not a problem because this has the correct number of nodes. The problem is here in the connected nodes. The connected nodes has 159 and we should have one more. No. Huh. That's correct. What? Okay, let's move on. Let's move one step. Maybe it was the copy thing. So the part nodes, if that's 47, then we might be on track. Yeah, that seems good. You know what? Let's continue. Oh. Oh. X not in list. So the part nodes are the 47 ones. That's because of the node pop. Can I just pop it? No, pop would be bad. Because that's something with the order. Remove node is correct. The problem is that this node, by the way, the linter will slap me with that. Let's make that node temp and remove node temp. And let's, yeah, I know it's not pretty. It's not pretty, but in this case, I would do it like this. So basically, I would assume that it will work now. And if that's the case, we can finally move on and see if we have something more with the performance thing going today. So if it's working now and has the 500, then the problem was with the self nodes because that is by reference. And that is one of the biggest, I would say, no, it's not a beginner mistakes, but it is one of the biggest mistakes you can make as a programmer. Confusing by reference and by value. All right, yeah, it was that. So you see the 500 newtons are now on both sides, and now I would say that this should be correct, right? Now, what was the problem here? See, node stack is self nodes, and I did not have the copy. That means that I just have said, please put the pointer which points to self.nodes, which are all the slave nodes, to this variable node stack. What is a pointer, or what's a reference? Reference is just an address. Like, where does this live on your memory? And if I just give by reference, yeah, this is not by value, by reference, give that pointer to somebody else, I allow node stack to manipulate what's in here. So basically, when I did this node stack.pop, which removes the first element of the stack, it removes it not just from node stack, but also from self nodes. So that means it's not there anymore in the slave nodes. And that would not be a problem if I would never use slave nodes anymore, but it obviously is a problem always, but it would not have occurred as a problem if I would not use the slave nodes anymore. But I did use it. You see it here? So set connected nodes, intersection self nodes. So I say what's common in the self connected, in the connected nodes and in the self nodes, in the slave nodes. Yeah, what's common? And if one is missing a node, the intersection will miss that node too. And that's what's causing the 500 being 480. So always pay attention to if you have something like a stack, something where you manipulate something, where you remove something, then you have to make sure that you initialize it by value. By value means you take that object and you copy it into a separate object and then point a reference to it into the variable, right? So node stack is its own thing. That means self nodes gets copied somewhere else into memory, and node stack has then the reference to this copy of it. And yeah, so this is a beginner mistake. Yeah, I'm sure also advanced user make this mistake from time to time, but it's an ugly mistake. All right, but we have solved it. Just a performance issue. The performance issue is still something which I don't like. Yeah, but now let's follow the simple rule. First, make it run. Secondly, you make it fast, and then you make it beautiful. So this is what I think is a good way of approaching things. Now, yeah, I know it's not good by no means in performance issues, but let's make it work first. And that means we have now some linting and some testing to do in order to be able to commit it. Because I think now is the time where I have a solution at least. And yeah, then I can, if I commit that, I can work on the performance issues on another time. So task lint would do our linting. And for sure the linter will be angry with me. Yeah, random is imported but not used. Yeah, we use that for writing out the elements, so we can delete that. I can't believe that. What? I'm writing good code here? Well, I'm not complaining. That's okay. Now then, let's do the testing. And this will fail. Okay. Wow. Wow. What? Module readers? Okay, we have two tests failing. Error collecting SPC forces import error while by importing the test module. Okay. Something like an invalid name. Did I just change it here? Yeah, the master node should be a node, right? But basically, it's complaining about something different. Ah. I see what the problem is. The problem is that it doesn't. Yeah, Alex, that's something like this is normal. That's something we have to get used to. So the problem is described here. It says that the import KD tree, what the hell is SciPy? And I think that the reason for that is that we definitely have added the SciPy and stuff like that to the TOML file for normal use, right? So the dependencies. But I think, seems to me that you would have to add this to the run dependencies, to the development dependencies as well, which seems odd to me. But let's see if a task.run. Oh, task run does not work too. Interesting. So running it, because here we do have to be careful. If I press F5, it will get executed in the base or whatever I'm in here environment. So I think the problem is still that we don't have it here. Something is not making up. What's here's problem? Entities no key error. Eh? Okay, let's think about what is task run doing actually. I think, yeah, this makes sense that it is failing because it may just execute NPC tools. Because the playground is not really that what it is, right? So we would have to adapt the NPC tools to be running with the new method and ditching the old one. But to be honest, this is not really what I'm interested in. I want to see if it can work with NumPy and SciPy. Let's see. Yeah, something like that. Oh, is that correct? Not sure if this is correct. Where was it? It was in entities, right? Ah, small letters SciPy. Okay, so task run again. If it now fails with the module error, it's not a problem with the dependencies of development. No. See? So this fails at NPC tools line 116 and it has the imports. So basically, but I'm still in shock that it is like that. Yeah, but on the other hand, maybe it is right. Maybe it is like that. And we just have, yeah, basically, what does it matter? It's not that we are saving us too much trouble here. So NumPy and SciPy should be then in the development dependencies as well, because the testing requires that to be there, right? So we do a, can we do just a task install? No. PyPoetry, yes. Run poetry log, no update to fix the log file. You know what? Log file, goodbye. Then let's do it again. Okay. I'm still not sure if it really did do what I wanted it to do. So poetry update should be reasonable. Okay, and then poetry install. Okay, then task test. Now let's see if it can now work with SciPy. No, it cannot. That's strange. Okay, let's see. Let's look into the task file. Poetry run PyTest. That's all good. Hmm. That's strange. It seems to me that it is. Let's quickly do maybe something like. Can we go and make sure that we are in the venv directory and then do a task run? It fails at the known location. Task test will also fail at the known location. Why does it do that? It should be there, right? It should be there. The following packages are already present. Yeah, yeah. Same thing with SciPy. So it's there. So it is there, but somehow the poetry install did not work. Maybe I have to Google for that one. So it does not find the module named SciPy in the location where I would say, yeah, then maybe this poetry run PyTest is not maybe the best thing to do. Hmm. So it seems that it is definitely a problem. Which also occurs for different ones. This works correctly in the version of Poetry 0.12.4. Looks like the fix came from 0.12, installing the current project in editable mode when you run Poetry install. So now PyTest can find the current project without needing the project for the manually added to Python path. Poetry add dev PyTest for it to work with Poetry run PyTest tests. Yeah, well, this is done. Okay, what version of Poetry do I have? Uh, okay, so Poetry should be well above that fix, so this cannot be the problem. Um, so basically that problem is pretty common, that PyTest is not finding the modules. Okay, let's make something different. Let's deactivate this thing and then let's make a poetry shell, because now I know I'm now in the poetry shell, which is basically the same thing as I would do with the activate. And now if I say pytest, this is not there. Okay, here I have the problem. But what I'm thinking about is, why do I have the poetry run pytest here and nothing with the python dot minus m here? Why is that not something like this? No, that's the same thing. Yeah. That doesn't help either, I think. No. That's strange. Sorry, to be honest, I'm having no idea why this is not working. So it seems to not have poetry correctly configured. And I'm not sure why. Let's delete the log file and let's do a poetry update. Yeah, the log file is not a problem. The problem is what I find online is pretty much local modules, but not global modules. So I think we have to sit through that. Matplotlib has a version where this is occurring. But I don't think I have matplotlib as a dependency, right? No. But maybe NumPy has it. So basically what I think I'm still thinking it's a poetry issue. Yeah, I am not sure. Let's do the deactivate. Let's try something. Let's try deinstalling PyTest. If that's working. So that we are sure it's not it's actually yeah. Yeah, interesting, right? It has something with the alter screw forces, yeah. But this is the Venv, right? Hmm. Yeah, now we have that, but does it help? Hmm. Now Poetry Update should install it again into the correct. It doesn't? Well, then it should fail at the beginning because we don't have PyTest. Yes. That doesn't make sense. So let's remove the log file, do a poetry update again, and then a poetry install. Why the hell does it not do a installation of PyTest? What? PyTest is here. That's interesting. That's very interesting. I'm not sure why this is. You know what? Let's make it clear. We just delete everything in the Venv. Okay, I cannot do that while this thing is open, so I will close. Yes, I know. So we'll close it and delete it manually. Okay. And now open Visual Studio Code again. So no venv again. Then let's remove the log file and then let's do a task install. So this should do a complete new virtual environment here. That would be good. And install everything which we would need. So also PyTest, you see, yeah. SciPy, yes. Yeah, sometimes you just have to remove everything. Does it work now? Does it work? Yeah, it does. Okay, so what was the problem? You saw that glimpse that I had a project called Hyperworks Screw Forces or something like that. I'm not sure even what that was, but it's not the Hyperworks tools I have here. And so it was installing PyTest in a different directory, which had nothing to do with this installation here. And so it used that one. And then it didn't find NumPy because, I don't know, PyTest didn't have the reference to the NumPy. Yeah, okay. But this is now much better. So it finds the test correctly, and now it has the first problem that we have this build node to property, which is failing. No, we have here something. SPC forces test module. Build node to property. Basically, this is not needed anymore. Because I think build node to property can be removed. We now have something better, right? We now have something better. So this whole method, it served us, but I think we can. But do we? I'm not. I'm not 100% sure. Did we use it here? That's the question. Yes, we did use it, so I cannot remove that. Maybe rename it would be a better idea, but this is basically not really building the property node to property. It doesn't return anything. So basically this could be removed. But on the other hand, I don't really care that much. But the renaming has to be has to take place somewhere. Okay, not remove it. But we have errors here. So here we have an error, and what is the error? Node key error. So the problem it has is on the same line again. It's always here. And it seems that the problem is it cannot do the integer, or it doesn't have that. Node IDs to node. Node IDs to node. Because, yeah, I don't have that. I think that's the problem. So you see, we have here a master node and slave nodes. But the problem is that I don't have the grid lines for it. And that's a shame, because I should have them. Let's add them. Something like this. I mean, the coordinates doesn't make any sense right now that we have them. Let's see if that helped anything here. Yeah, we have now a different problem on a different method. This is this method. Let's maybe copy something from it. So same thing from 2 to 7 should be added here as well. Right? I'm not sure if the coordinates make a difference. Maybe later we should change it that it has a difference. Ah, forgot one. Here we have an 8th node. Now, what do we have here? Key error again. 2, 3, 4, 5, 6, 7, 8. So the nodes are there. Then we have hex elements, which have 1 to 5. And then we have 3 to 8. But it still has the... where does it have the problem? On model reader 203 here. Where do the nodes come from? Mm-hmm. No, that's not a problem, I think. Because a dictionary is like that, it has a unique ID, and then the coordinates can be whatever they are. So that should not be a problem. But we can check that by going here and just printing. Whoa. By going here and just printing nodes before. The problem was once below, right? So the node IDs were correct. Yeah, so we can just print the node IDs. Now we should see something like an ID. So 3, 4, 5, 6, 7, 8. And it complains that it has a key error here. And the only key error is that the ID is not in self nodes ID to node. And here we have the grids. 3, 4, 5, 6, 7, 8 is there. Let's maybe print a self nodes ID to node 2 and see what it is. But it should have... oh, sorry, wrong. Oh, what? No, sorry, wrong. I have to do the task test, not press F5. So this should have 1, 2. Huh. What? So this has just 2 nodes. Hmm? So I'm at a RBE keyword, right? So let's see where I'm at. I'm here. And this then should have just 2 nodes? No, that cannot be. Ah. This thing, maybe? Is it a mocking? What do we mock? We mock read nodes. Read lines, read nodes. This is the problem here. So why do we have that? Yeah, maybe. Do we really have to mock that, to be honest? I don't think so. So we have the FEM file reader, right? And we have this read nodes. And the read nodes, I honestly don't think we have to mock the read nodes. Because the read nodes, well, maybe maybe we have to. Huh? Something private? I'm not sure. Let's simply try that. I'm not sure if we have to mock the read nodes. Because if we have something correct here in the read lines return value, right? We can do something like, yeah, okay, we have to mock it. Yeah. You see, the problem is that in order for this to work, because I execute the read nodes method in the instantiation of the FEM file reader. That's the reason why I have to do that. Yeah, so let me back off a second. So this is it's interesting. Maybe it's also a design flaw. So the FEM file reader, if that's initialized here, we have some values which are assigned. Yeah. First one which will fail is the read lines method here. I can say that the self read lines method has a return value, but still this self.file content will not be executed. I'm not sure why though, but if that would work as intended, then we had a file content and would not have to do something like this. To be honest, I would like to try it out either way. So I will just copy the test model reader into a text file that I have it. If this fails, then I have to just back up. Because it should not be mandatory. So read lines, I get that. But this one, no. And this one should not be necessary. But I think we will fail at exactly this line. Because I'm not sure why this is not working. The mock read lines is this patch method and the return value is something like this. I'm not sure if this is not how it's working, but yeah. Let's see. If I do the task test, this will fail at creation because read node says nothing. No, it fails even before that because there's no method to mock. Okay. But that's not a problem. So wait a second, where are we? Test. Get rigid elements. Wait a second. I have to do that one more time. So we are here in test model reader, right? So this is what we have been doing. It's not failing anymore? What? No. Wait a second. Yeah. Sorry. What did we change here? Task, test, get rigid elements. So here, lists differ, but it's an assertion error. Hey man, I think it worked. I think that worked. Okay, I would go with that. That would make me a much happier man if it works like this, because then we also check that. So we would really not need something like this. So we don't need that. We don't need that. So it should still work now. We would not need that. Let's see. Yeah, then for sure the assert equals would differ, I think. No? No, it would not differ, I think. Because I'm testing something different here. Yeah, sorry. Alex, I will back off. I will back off a second and explain it a little bit more slowly that is of value to you. So basically, what was the problem? See, the problem is what this mocking thing is doing. Um, when you don't want to provide data for your tests, where you can test it like you would do with a real FEM file, then you do something like what is called mocking. Mocking means you jump in and say that this method, which is normally getting a path to a file, reads it in, returns the values, this actually does not do that anymore because you don't want to specify data for it, but you just specify what it returns. So basically this is what it's doing here. So by patching this readLines method, I say, okay, this readLines method is a private method of the FAM file reader. And this lines method will return this. So I say, so you have to be a little bit careful about how this is referenced. You have a patch here. This is referencing the first method here. And then you can say this method, the return value of it will be this thing. And this is the same thing as if it would have read in a file with this content. So you can specify your file on the go and don't have to call a file directly from the system. So, but this did not work before. It did not work because somehow the return value was not assigned. I'm not sure why exactly, but it did not work previously. Now it seems to work, and now it's much easier to understand because before that, I thought you would also have to patch another method called read nodes. Because both of those methods, read lines and read nodes, they get executed in the FAM file reader instantiation method. So whenever I'm creating this file reader, I will initially read in the file with the read lines method. You see that by this line. Self file content, so this is the file content, will get the output value of self read lines. And self read lines will reference the file path. And if the file path doesn't exist, it will throw an error and just exit. But if I specify that the return value is a certain list of lines, then this will be fine. So self file content has then something, and this is needed for this read nodes method to work. Because if you go to the read nodes method, see, it loops through all the lines of file content, right? But basically, I'm not 100% sure if it really works. Let's make a print line. So there should be now, if I do a task test, there should be now a print line statement of the grids I specified. And yes, they are. So basically, this assignation of the return value worked. So we can check that off. If I turn back to the test, this is what we have been doing with the patch thing. Okay, so that's it. And now we can now start and see if we can fix the errors in the task. And if there's any questions to that, don't refrain from asking. I'm happy to explain that. All right, so we have a few tests which failed. For example, here lists differ. It differs at this test, get rigid elements, and there's something like which it should be from 3 to 8. Let's see where this is. Here. Yeah, basically the nodes will be something different because the nodes will be now instances of nodes, right? So it's not a list of integers anymore. We can say the node IDs equals node.id for node in FAM file reader, widgets, whatever. So I'm just making something which I can then compare to what I have. This could still fail because I'm not sure about the sorting. Is that working? Can I do... This should be a list, right? So I think there should be something like this. And this is a sorted list, so that should work. Let's see. Yeah, it's pretty interesting. It's basically very important to get that concept, because if that's not working, then you would have to use files. And basically, I did that for a long time to actually create files. But you're ending up clustering your file system with all the test files. And then what you do with them, you commit them, yeah. So if the method changes, the test has to change, you commit them as well. It's pretty, yeah, normally it's better to not do this. So the node IDs is none. That's interesting. So we still have the problem with the none thing here. So what is this? The rigid elements, the rigid elements, and then you have slave nodes. And I say there should be a node ID for node in this rigid nodes. I think there should. Let's check it. So rigid has a list of nodes. This nodes... Oh, no, it does not get removed. But how is it filled? It's filled as at initiation. So that makes sense. So it has that. But a node has an ID. This doesn't make any sense. Okay, let's see. So we are here. First of all, let's get rid of these things. This should be in the FAM file reader. Let's do the task test again. And let's see now. So none is not something like this. Yeah, I'm still a little bit not sure about this sort method. Let's just remove that, and let's print the node IDs. And let's maybe also print the nodes. To just see if that worked. What the hell? Wow, okay. So leaving that sorted away did do it. No? No, I did not do it. Huh? Did it? I'm not sure. Test rigid elements. Wait a second. Let's clear it and then do a task test. Fresh. What? But why it's not printing it? And why the hell do I have all those errors? I'm really in shock a bit. Can I find something where I... This is all old data, right? Yes. So I'm not sure why the hell does this clear not work. Let's maybe do a fresh console. The printing also did not work, right? Why? So the sorted thing did not work. I still am very bad at remembering the syntax for it. Is it like this? Well, this would let me commit it. Yeah. Seems like it, right? But the printing? What's with the printing? Is it those empty lines? No. If it's empty, then that would make... No, that would make no sense. Hello. The test model reader did get executed, but somehow I think it always... Yeah. Let's make it fail on purpose and see if the thing worked. But I have to see it, to be honest. I have to see it before I believe it. Yeah. So before the hello, I print the node IDs, and this is exactly what I would expect. All right, I would say we solved that one. All right, not bad. So I would say the tests are now... The tests are now working. Yeah, yeah, you see, but the problem is that the print hello did not work until the test failed. So I had to make the test fail, then the printing was displayed. That's also interesting. The PyTest will not give you the standard captured output if the test is okay, which makes somewhat sense, I would say, because you would not be interested in it if the test is being okay. So now let's do task lint and task test, and well, task test will be okay, but let's... Yeah. One thing would be formatted. Yeah, that's another thing I have to take care about. Do I have a task format? No. Oh no, one file would be reformatted. Test model_readers.py. Still, we definitely have to do the task format. This is not there, right? But there should be this run black. Isn't that... Okay, so there's two things to do here. The one thing is to make sure that the installation of the black formatter, which I'm using here, is also applied at the Visual Studio Code. That could be maybe a preference here. I'm not 100% sure, but normally there is something like a formatter. Sorry. There's something like a file. What is it? Is view preferences? No. It's interesting. I'm not used to going to the preference too much. Where is it? Isn't it file preferences? I would say it. I'm blind maybe. Yeah, preferences here. No, what should it be? Settings? Yeah. Let's see if we have something like a format. Normally you can choose a default formatter. Yeah, default formatter. Now, is there a black? Yes. Okay. All right. Now let's see, which one is it? This file. Save it. So now it should reformat it. No, this should work. No. Okay, let's add something with a task format. Format. Yeah. So this will format this one file. Then I can do the linting. Because the check with black is used to make sure that all the files are formatted correctly. Normally it would format on save. Somehow this did not work. With the task format, I'm forcing it to be formatted. And I like to keep that separate from the task linting, and with the linting just doing a check, because formatting is somewhat of a sensitive thing to do, and you would like to make sure that you do it only on purpose and not with a standard. All right, Alex, you have a question. What is poetry and lint? I'm not used to it. What is it for? Lint, I get it makes sure that the code passes certain conditions to get a good score. What's poetry? Yeah, poetry is the virtual environment. Yeah, just think about you having different projects on your machine, and the projects, they require different versions of the libraries they're using. And for that, you usually have virtual environments. That means the Python is not living on your system anymore, but it will be created with project-wise. That means if you can see that, you have a virtual environment folder here. Then there you have all your scripts and what libraries you want to use and stuff like that. But there's also your Python. So the Python executable is somewhere here, Python. Yeah. So if you just run it here, then it will be run in the virtual environment, ensuring that it uses all the library in the correct versions it's specified in this tool, for this tool. So you're making sure that the code works with the sets of libraries in the specified versions, right? So this is what you're making sure. The major benefit, besides the benefit that you can have different projects with different dependency versions, the main benefit is that you can share this PyProject TOML file. It's on GitHub, right? So everybody can download this and then install the exact same versions as you did, ensuring that it works on their machine as same as it works on your machine, because you both have the same configuration. I mean, just look at Stack Overflow. It is crowded with posts like, well, it works on my machine, but on my machine it doesn't work. Why it's not working? And this is making sure that you're having the same configuration. And that means it's project specific. It's not system specific. Doesn't depend if you're using your PC, your laptop, your mom's PC, whatever. If you just execute the poetry, it will install all the dependencies in the correct versions for you and create this little tiny virtual environment where you can start your code from. That's it. That's poetry. And I really love it, to be honest. Poetry is a great tool. All right. I think then we can start with that. Yeah, and you see also the poetry log file. This is more an explicit version of the TOML file, which exactly specifies what file to install, stuff like that. All right, so let's do first of all the poetry thing. So then we have playground, entities, widgets, model readers, and the test. Let's leave the test for now. That would be the basic implementation. I'm not sure if NPC tools is even something to commit for. Oh no, what is now? What? Key error. I did the task test, my friend, and it did find. Let's see what it find on the thing here. Is this again the thing where we had to specify that it always runs the tests? No. Here with committing, maybe the problem. I have to commit this as well because otherwise it will not fail. It will fail because the test. You see, the test was adapted, but I tried to commit a thing without adapting the test. So for sure this will fail because it committed it like this with the old test. But we have to commit it with the new test. So this should work. Hopefully. And then we can see at the NPC force, is there even something to commit here? No, I don't think so. Okay, let's sync that so we have our basic implementation of this automatic detection. I mean, it's pretty insane how far this got already. I think, my personal thoughts. Performance-wise, it's in the bin, yeah, but yeah, still, I think it's pretty cool. Now, now we are free to adapt it to the main method here. Right, so this main NPC tools method is the one which is executed normally if I do a task run, and this will fail because it's still using the old version. No, there's no. Yeah, I'm not 100% sure with what it is exactly what it's failing, but this has to be adapted anyway. And I think I will do this, but I think this will also be the last thing I do today. Before that, a little coffee break. Not really coffee, but I have to get something to drink. It's not so easy to talk like several hours, but without drinking anything. So I will be back in just 2 minutes or so. See you around. All right, I'm back. So now the NPC forces NPC tools rewriting. Let's close anything else. So it shouldn't be too different from what we did in the playground. So maybe we have something to do with the output, but that's that will be after. So basically what we're doing, we have in the main method, we have creation of the NPC force extractor and get NPC forces and then write summary. But this is after this thing. And the NPC extractor, this is the main class. And I think we have to change something just here. Now, what we have to change here. Paths can be the same. Then element ID. Elements 1D. Well, I don't think that's a problem here. We have a FEM file reader, that also makes sense. Then for rigid element in reader rigid elements. So this is not needed anymore, right? Sort nodes by property. I think this can be put into the bin, right? Is this even used anywhere else? Oh, it's used in the tests. Always good. So not here, but this here, it's using that one. Let's leave it for now, but let's see. This new method, this one. Some forces by connected parts. And not some forces by property. This is what we can do for sure. So this thing is then this thing. And then this should be renamed part ID to forces. Something like this. So this should be it. But I don't think this is really, because there's something which is not working, right? Let's see what this is about. So it has a key error, the property ID being requested. Yeah, because we don't build that. Yeah, you know, although I know we having much trouble now with the tests, let's just delete that because we're not using it anymore. Get NPC forces here. This is just returning the NPC forces, right? That should not be a problem. Is there there's part ID? Yes. Okay. Let's try it again. NPC object has no attributes or nodes by property. Yes, correct. I don't want to do that anymore. Okay, let's just forget about it. Let's compare that to the playground. So this is very similar to a section here. Node to forces. So node to forces is being requested, yeah. Then part ID to forces. And that's it. Yeah. So why the hell did we need this method anyway? I'm not sure. Maybe because of the property. Yeah, okay, let's test it again. Key error. Yeah, now we are in the writing of the things here. So the rigid element has still a property to nodes. That's not great. So let's see that we get rid of it. And let's see what it is. Property to nodes is a dict. Well, let's not use it then. Let's delete all this. Let's make our life a little bit more easy. Yeah, so we should do something like self part ID to forces. Forces or force? Let's do force for now. Because we have the sum forces by connected parts. and we sum up all the nodes, then we can do self.part. Forces is because it's an array. No. Yeah. Yeah. Is that correct? The part ID to forces. I think so. That should be correct. Let's see. Now, we have an output here. So rigid element and then property to force. This is definitely not right anymore. It's part ID to forces. Where does this come from? So write summary. Let's do that. Part ID. That doesn't make any sense. What? Rigid rigid element to part. Oh. So rigid element to part to forces, that makes more sense. And this should be then this one. So what I'm not doing is just some simple refactoring. So it's not nothing is changing. It's just the difference in name calling that the part ID is now something different. So here's part ID, here's part ID, and here's part ID. Okay. There's nothing with property ID anymore. There's still more to clean up, 100%. NPC has no attribute. Yeah, doesn't have that. What is this? Ooh. So I have to get the slave nodes. What do we have? Something which is regarding this. We don't have that. Self part ID to slave nodes. So this is being done here with the part nodes. With the part ID, so we can do that here. No, not here. Wait a second, I'm not sure if I would like to do that diff. Yeah. This could be it, yeah. So then we have something which we can use for output. Well, really? Okay. Let's see if I have another property here. Okay, this has to stay the same because I'm not having refactored this one until now. I have to change all the decorations and stuff, but that's for later. Part ID to slave. Okay, now the first run was successful. Now let's see what is the file we are using. So the rigid file. Now let's see. We can delete that and that. Okay, it did not work. It did not work by a long shot. Interesting. So now we are back to the beginning where we have multiple parts. So I think there's something still wrong. Still wrong with it. Now it's interesting that it worked. So because I printed that here. Let's see. So it is the problem with the output. Not 100% sure, but pretty sure. And there's something wrong here. What is it? Yeah, you know, who would tell me that in an instant? The linter. Oh, come on. What is that with the format? I'm really sure that there's some stupid problem here. Well, no. What is this? Removed lines. Ah, okay, yeah, then I don't care. So something is different from here to here. So no two forces, MP2 forces, reader get no two forces. That's cool. And then the rigid element, some forces by connected part and no two forces. That makes sense. So is that the same thing as here? No two forces is get no two forces and then some by connected parts. That makes sense. Part ID two forces is then being put into here. I cannot. Yeah, I can do that. I just have to change the config again. Not the venv, but the VS Code config should be then not the playground anymore, but the MPC underscore tools. Now I should be able to debug print that. It's pretty fast. I'm not sure why it's so fast. So we have 68 parts. Are you kidding me? Which model is that? This is the model plate simple rigid. Isn't that the same thing as I have here? Yes. So something is not making sense. Let's do a side-by-side comparison. So I have this MPC extractor thing. And this thing does nothing. So here's nothing really changing. And then we have this get MPC forces. Okay. Now we can compare that. We have the FAM file reader, right? This is the same thing. Then we have to build node to property, and then we have the reader get rigid elements. And then we did not do the element dot get neighbor. Yeah, that's not great. Okay, so we did not do something with the, what did I miss? Yeah, capital R. So there's no neighbor relations. And this has to be done. Yeah, let's run it again. And if it doesn't have the neighbor information, it should fail. So this is another thing I should implement. Okay. Does it now have some output which we like. Yes. Okay. So this is working now. Is that really -11? Just being curious if we might have an unwanted bug. So this one isn't it? But the other one could be it, right? Just cross-checking. You can never be too safe. So it's until we have this ID change. That's why I know where I would stop with the parts. Yeah, -11. Okay, so that is also great. All right, so this works fine. First of all, let's commit it. Therefore, I should do the task test. And there I will get shot in the foot because I removed some methods, and so there's no sum forces by property. Which is a good thing because we now have to do something with, well, if this will work, well, test sum forces by property is not really valid anymore because there's nothing there. Basically, I'm not sure how this is working even, because the constructor here expects a node here, and then a list of nodes, and this is just accepted, right? Okay, so this whole method here is pretty damn useless. I think it's not possible to really do that without I mean, you cannot do that with elements anymore. So the method is not there anymore, so I can just simply delete that. Yeah, basically this complete test is this test is for the bins. So I would have to write this again, but something like this. But this is not so easy to do because you would have to have connected parts and stuff like that. So we would have to patch something, and I cannot do that today, really. So no, I will not do that today, but there is something to do for me. Okay. We have another test failing. Test rigits. NPC has no attribute property to nodes. Yeah, that's right. Skip that. Okay, I will do a to do here. Testing is not good right now, especially for the rigits. All right, that worked. And then do the task lint again. Why the hell doesn't it do that? Normally, there is a preference, which is format at safe or something like that. Format on safe. Yeah, why not? Why not? Man. Stupid. It says test widgets is has a yeah. Don't get too much entangled in this. So format, task format, task lint. Test is already good, so we can commit that. And I think then we will merge that and create another issue for the testing for a future session. All right, so okay. Adapt main method plus test removal. Yeah. Fingers crossed, right? Yeah, it did work. Yeah, so we can commit that. That's good. and then I will just we'll just merge it. I mean, the testing is screwed anyway. We have to do that at another time. So for today, my brain is cooked. There's not much left in it, but just my will to go to sleep. Now, let's do the pull request quickly. So, myself, labels is enhancement. Project milestones we don't have. Closes 15. Yeah, normally you would have to go through all of this. Let's quickly do it. The task file, I would say that's okay. We checked that already. Then the log file, that's also okay. Toml file, we changed the numpy scipy thing. If we need that, that's maybe to be discussed, but it's not really bothering me. Then the data structure entities, this is the main thing. So to get neighbor, get all elements, get all connected nodes of the class node. So this is the main one thing. Yeah, viewed. Yeah, it's basically it's just yeah. I have to tell that every time. I will not check it this properly. Maybe at a later stage. But for now, it's just an easy check. I mean, we have the testings and we have model validations and stuff like that, so it's okay. But just think about it. If I would have to do a proper pull request, I would take much more time and do comments and stuff like that. Okay, some forces by property is gone. Some forces by connected parts is there. Yeah. Basically, it did just change the method to be using part IDs instead of property IDs. Maybe that's also a bit of a problem because the part IDs are random right now, right? So maybe there should be something like a information where maybe the centroid of all the slave nodes which are belonging to part ID 1 are located, because otherwise you cannot really tell it. Yeah, so this has to be checked. Okay, then the test thing got removed. That's a good thing. No tests, no fails. Then the NPC tools, we just adapted that. We just did a bunch of renaming property to part, but other than that, it's not really that much what I did. And then we have the playground neighbor, which is not really that much of an important file, but just for us to play around with it. Then we have the model reader. There we did change the node IDs to be proper instances of nodes and the other things too, the elements and stuff like that. So that's also great. And then we did some more testing adaptions and that's it. Yeah. Okay. Okay. So merge that. I would not bother even printing something like a looks good to me. So delete branch, we have that. And then we have to make an issue for the tests that I don't forget. Add more tests. Because the latest changes did are not covered yet. Yeah, I think I will do that off stream. I mean, that's not that of an important thing. So label, that would be not documentation, no. Enhancement. That's okay. Submit. Okay. Should we do one last run? I just saw that I have another model with 2 RBEs in it. Yeah, I just would like to test another model before I can safely go to sleep. So NPC tools. Now we can change the input file down here. The 3D bolt is, yeah, it's interesting, but I think the rigid 2 would be even more interesting because we have here three separate RBE elements. And if that's working correctly, that's maybe interesting. So Then let's just do that. That's just rigid 2. And now maybe nothing works. And I will be crying and go to bed. No, let's see. Task run. Maybe it's working. Hopefully it's working. He never did more than one RBE element, so that's maybe a thing which... I mean, I will be happy if it's just working without a failure. And if the output is not that completely correct, then we can fix it maybe after. But not today. Today I think I will close the stream after this. If it runs correct, then great. If it's not correct, then maybe not. But you see, again, the performance issue is really bothering me. And I think this will just increase with more RBEs and more elements. Just think of a giant meshed part, and then you have 100 RBE elements there. And for each RBE, it will just grow into eternity. Ah, I don't like that, to be honest. All right. Okay, the output file. Seems not bad, though. So it correctly got the 3 different RBE elements. It correctly got the 2 different part IDs. It seems balanced at the first sight, right? And the total balance is somewhat around 500. Yeah, okay. Alex, because it's you, I will just talk a little bit about the neighbor detection on the code, because I think that's also where the money is at, and then call it a day and head to bed. So, neighbor detection. Neighbor detection is pretty interesting. Neighbor detection is important because it's neighbor detection itself. Neighbor detection itself is a way of making the algorithm I have to use more efficient. So just think about what I would need. Where's my hypermesh? Here. So you saw that RBE element, and we have to detect the 2 different groups, and we have to detect it independently, right? The one group of the blue, the one group of the yellow. The thing is, if you would like to see that, maybe I have just now an idea which is maybe even better than doing the neighbor detection. But let me just think about it. So the idea was, if you would like to check whether a element has a slave node of the RBE or not, and is connected to the same part, you would have to guess which of the elements are in one distinct group. And having neighbors is the information that from one element, which are the ones attached to it. RBEs don't count, right? Because if you do the select by attached, it will just select everything because it's attached by the RBE. Basically, but I would like to steal that algorithm because it's damn fast from the by attached. There has to be some better way of getting these things. But basically, the neighbors here, to get the neighbors, one property of a neighbor is that they share nodes. So that means those 2 elements have the same nodes, mainly those 2. So that means those 2 elements have the same nodes, or some node is the same. By the way, I just thought of a thing which could make the thing better. Wait a second, I have something which is not committed. Yeah, we can stash that for now. Stash that, discard that. Just an idea I just had, which makes our tool a little bit better. Because, and this is a very quick one, but it's a quick fix, and it will enhance the to understand the neighbor things. So we said that it would be one property of 2 elements that they are neighbors, that they share nodes. They have at least one shared node. Now, where is my neighbor? It's not there. There should be something with a neighbor. Ah, sorry, no, I have to fetch. Yeah. So here's the get neighbors. And the get neighbors, I will explain it in more detail, but the one quick fix, I think. Yeah, okay, no, it's already there. Yeah, my question or my idea was to, if I have at least one node, then I can say it's a neighbor and stop counting the other ones. Maybe that's still the case, but I think the intersection makes this very efficient. I think. Hopefully. I hope so. Okay, but now let's get to the actual implementation of the algorithm. The problem is that you would not do, or you would not want to do the simple approach. The simple approach is you start with one element, then you loop through all of the elements and ask the question, do I share a node with this element? So for example, you loop and you're coming along here and you, no shared nodes. Yeah, then no, 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 no. Yes, I'm a neighbor. Okay? I'm a neighbor, I'm a neighbor. And then, so you, you're doing for one element, you're doing a loop over all the elements. And that's stupid. That takes so much time. If you remember at the beginning, somewhere where I wanted to debug why it's not working, I did this with the real neighbors. And if you remember how the counter went up to 19,000, it was pretty slow. So it would take us, I think, 5 minutes or so to even do one run of this very simple model with just 20,000 elements, right? So that means the looping thing is not a thing. You should never do such a thing. So better make use of something which you could do with data structures. And this is maybe the, if you're getting a, if you take away something from this talk today, then it's this. There's always a balance to be done between being fast and having memory requirement. You trade memory for being faster. So you have to you have to come up with a data structure which allows you to find the elements of the neighbors faster. And yeah, one of those structures is a k-dimensional tree, and I cannot explain it into the complete detail until the implementation of it. But just think about it like this: if you had a folder structure in a folder structure with files and folders in it, to find the next neighbor files is pretty easy, because you can just think of what files are in my folder, then I go into the parent folder, and then I go into different subfolders, and I will grow like in a structure up and down directly surrounding my point of interest. And the KD tree is doing somewhat the same thing, but with multiple dimension. So just think of something like this. You have 3 dimensions here, like the coordinates in space, and you put those 3 dimensions for every element. You calculate the centroid, so a node, which is just a position of this element, into a KD tree. So a k-dimensional tree, a tree structure, like a folder structure, but more dimensions than up and down. Now with this, you can then ask for the next X neighbors. For example, I calculated that the 30 next neighbors. Why so much? In the 2D, we just have 9. But in a 3D case, you might have more. And for those 30 neighbors, you just check if they are sharing nodes. Because in the 2D, if you just think of the next 30, yeah, it will do those 9 or those 8, but it will continue. And you have to check then, is this element sharing a node with this? If not, it's not a neighbor. So that's this thing. Yeah, this is the KD tree. And Yeah, you're getting the 30th neighbor, the 30 nearest elements, which could be neighbors. Then you're checking with the are they sharing nodes questions. No, k is free. So you see, it's a bit hidden. So the KD tree gets a NumPy array of chords, and chords is the coordinates has 3 dimensions, right? Element centroid has 3 dimensions. So k means the number of dimensions. Here's a small letter k. This is more or less the next. Wait a second. Should be. X is array like, k array like. I understood it that this would be the 30 nearest neighbors, but I may have to think of it if that's. But because I'm not specifying k any as the big letter k, but normally that should be dependent on the tree, on what array like data structure I put into it. But maybe I have to research that. So small letter k is just a 30 neighbor, which should be then here. Yeah, but we can check that if it's it should not be working with k equals 3, because then where do you specify how many elements you would like? And you have to do that with the query. All right. Yeah, so this is how you're getting the neighbors. So and if it's a neighbor, so if they're sharing nodes, then you just make a link between those two. Yeah, that's it. But there's some tricks to it. Now, the idea I just had was, is there maybe a way of just looping through all the elements once and then doing the... No, I'm not sure. I'm not. This is just me wanting to go to bed and having some thought, which sounds like totally clever, but is actually, I think, pretty dumb. Because I thought of something like this before, and I concluded that it was not possible. But if there was a method which could loop through all the elements once, and if I... Yeah, well, to be honest, there is a way of improving performance quite dramatically. The way is, does it make any... Well, hear me out. The idea is this. You loop through all the elements, and if an element is connected to an RBE element, then you just add it to a list. And maybe it's a dictionary. Dictionary meaning you have the RBE element as a key, and then all the elements which are connecting to a slave node of this RBE element. So this would get you something like this. This would get you some like circular shaped element forms around this, right? So the first line of elements, this would get that. This would also get the lower one, and you could not differentiate between those two. You would get all of those. But just think about this. If you would have something like so. Those elements, to check then for connectivity, would be far easier than doing it for the complete model. I'm not sure, because if you would have some element which is missing, or 2 elements which are missing because there's not a connectivity, then it would fail and it will not get this as well. But you could do something like this as a primary thing, and then just adding a number of times. Let's say just 10 times. 10 times. You would just add all the neighbors you have. Then you would end up with something like this. Maybe. But it's not the whole model. And then you're doing the group selection thing here twice and get the things. So I'm pretty sure that this would boost our performance quite drastically. So that's a thing to do at another day. It will not change the code dramatically, but still too much that it is not a 5-minute job. You basically have to get, where is it? I think at the widgets. You would have to adapt this get all connected nodes method somehow. So I think there is a possibility to make that a lot faster. But yeah, so one step at a time. For today, it's more than enough. It's already almost 3 hours streaming for me, and so I have to now call it a day and get some rest. But thank you all for being here, for contributing, for questions, for anything. Alex, thank you very much for the questions. It's been a pleasure. If there's anything else I could do, we talked about the things with the coordinate transformations and stuff like that. I'm very happily looking into it. So that could be a thing in the future. And also TCL scripting. Although I'm ranting, or I did rant a little bit about TCL, it's still an option which I could do. Ines Kurt, thank you for being here. Good night, everybody. Thanks for attending. And yeah, so if there's anything, just leave a comment, write me an email, or anybody else. All right, see you guys. Thanks for being here. Bye bye.